Hello, welcome to this lecture video. This is the third lecture video, a part of the Linux concepts series that I've developed for my introductory Linux course for use for students in both my introductory and advanced Linux courses, but also for other viewers that are ultimately trying to learn more about Linux. The previous videos we discussed what would ultimately be considered basic command line aspects. We discussed ultimately what a command line interface is, what the shell is, use different aspects of the shell, such as the tab key for auto completion, or to provide us with a list of commands that start with certain values. The history aspect of the command line structure that allows you to recall certain commands stored in the .bash underscore history file located in your user's home directory. And we also discussed the use of ls, which is ultimately use a list content directory, as well as the cd command, which is to change directory. We also discussed the difference between internal and external commands. And ultimately, we discussed the use of cd to navigate through different directories, again, through the use of absolute and relative file paths. And finally, we introduced regular special characters, which we'll ultimately touch more upon in the next few lecture videos. But today's lecture video is going to be focusing on, in terms of the advanced command line aspects, it's mostly going to focus on data streams and two concepts, redirection and piping. So ultimately, data streams are effectively, excuse me 1 second here. Make sure I'm sharing the correct. Okay. So command lines ultimately place information into different data streams. And sometimes these data streams are referred to as file descriptors. And ultimately, the data streams really just depend on what the data is. Keep in mind, Linux thinks of everything as files. They even include look at these data streams in terms of special files themselves. They're typically referred to as three common streams in Linux: standard input, which can also be referred to as std_in, standard output, which can be referred to as std_out, and standard error, which can be referred to as std_error. So again, we have data streams. This is where the command line puts different types of data into different types of streams. We have our standard input, standard output, and standard error. Now, in terms of grasping these concepts, standard output is typically the easiest one to grasp. It's the simplest because it's simply just text or data that is produced by a command and shows up on the screen or console. And ultimately, it's anything that is not an error message. Standard output can ultimately typically be confused with standard error because in both cases, some type of text is displayed to the terminal. When it comes to standard output is a result of command typically being successful. Standard error is ultimately going to be displayed to the terminal if there's an error message associated with the command. In other words, you did something wrong or didn't have the proper permissions. Some examples of standard out would be, for example, issuing the ls command. And as you notice, as we issued the ls command previously, it actually lists contents of a directory, so it actually outputs that to the terminal. Therefore, that is standard output. Now, ultimately, we have standard error. Again, this is typically confused with standard output because it's also text being displayed to the terminal. The difference again being is that standard error is anything that is an error message. It has nothing to do with standard output. However, keep in mind that in some cases when you run a command, you'll get both standard output and standard error. Well, how can this be? Well, keep in mind that these streams are parallel of one another. It doesn't mean that, so basically if there's standard output, it's not only standard output. It can't, ultimately since they're parallel, you could really have standard output and standard error displayed to the same screen. Now, by default, it shows up mixed in the standard out stream as the errors occur, but they are different, but they go to the same place. In other words, what happens is when you issue a command that has both output and errors associated with it, it's going to display both of them. It's not going to break them up between the two. So it could be output, then error, then output, then error. And also, even though they are the same thing or not the same thing, again, standard output is ultimately text displayed to the terminal that isn't an error message. And of course, standard error is an error message. They do go to the same place, which is the terminal. So for example, Let's say I issue a command ls-l, which again lists permissions of a directory or a file, and I include a file that doesn't exist. So ultimately, in this case, standard output could be anything that is referring to the files that do exist. Standard output would be anything that refers to the files that don't exist. Now, file1.txt and file.4text are listed differently in the actual command output below. There is ls-l for xaa, which is an actual file, but then there's another command that has ls space -l and has xaa and baa. What this is showing me in that second command is that BAA does not exist, or in other words, we cannot access it because, well, there's no file or directory. But XAA does. In this case, anything that's red, this is error. Anything that's blue, in this case, here is standard output. We also have standard input. This is anything that's sent to the command, utility, or program. Basically, it's anything that's read into the terminal by you typing something into it, or it's a file being read into a command. That's typically what it ultimately is referred to. It's typically a file that's read into a command, but ultimately anything you type into the command line interface would ultimately also be input. So therefore, the standard input. Now keep in mind, input could also be standard output or errors from another command. This is where we discuss the concept of piping. And again, I'll discuss this later on in this video. So is it still not clear? Ultimately, what you want to understand is standard input is anything displayed into the terminal by the use of a keyboard or a file being read into a command. Then you have the command is ran, and ultimately it provides either standard output or standard error that are both displayed to the terminal or the display. Now again, we have the three data streams, right? We have standard input, standard output, and standard error. But ultimately what we understand is there are ways we can actually manipulate these streams. And the two major ways of doing so are through the use of piping and redirection. The piping is utilizing the pipe character, which if you're wanting to use the pipe character on your keyboard, it's going to be the shift key followed by the backward slash key. It looks like has like two little vertical dashes. The pipe character itself is actually going to be one straight line. I'm not sure why the actual key looks different than the pipe character itself. But if you hit shift and that key, that'll type the pipe character onto the terminal. And I'll show you this here in a little bit. Now with piping, a pipe is used for chaining two or more programs output together. In other words, what it simply means is you take the standard output of one command and use it as standard input for the other. We also have redirection. Now you can also do standard error with that as well. Now we also have redirection. And redirection basically changes the destination of standard output and standard error, and in some degrees standard input. With standard input, typically it's just used to read a file into a command. But with standard output and standard error, typically it's used to change the destination of where that particular data stream goes. So I can redirect standard output or standard error to different files. And these are probably two of the most valuable shell functions you want to understand in the Linux world. So again, we first have piping. Piping takes the input of one command or the output of one command and uses it as input for the other. And it uses the pipe character, which if you remember is the pipe symbol shown here. Now the pipe will sit between two commands. Standard output will be on the left of the command and standard input will be on the right side. In other words, you'll take standard output of this command and use the standard input for this. So I have the command cat/etc/passwd. The cat command will simply display the passwd file. This file is what typically is the file that actually holds user information, such as usernames. Now with usernames, there's also user ID values and group ID values that are associated with them. So it includes those. It also includes typically the user's home directory and what default shell they're using. Now I could just issue this command here and it would basically list every single user on the Linux system. Or I can take this output and pipe it into this command here, which is grep space Kyle. Grep simply stands for grab regular expressions. And what it does, it will search this file for any input that matches the string, in this case Kyle. And rather than returning the full file, it'll simply just return aspects of the file that include the search term, which in this case is Kyle. So it takes the output of this command and uses it as input for this command, which then will display a different type of output than what would have been utilized if I simply just typed this. And I'm going to show you this example here shortly. We also have redirection. This is frequently confused with piping. Again, one thing you want to understand, piping is taking output of one command, using it as input for another. It is temporary. Redirection is permanent. And it's typically going to be used more frequently so than even that of piping. Or in a lot of cases, you might use them in conjunction. Redirection is typically done in terms of, because what it does is it actually writes to a file. That's why it's considered permanent. And it can do so in one of two ways. It can be done to overwrite a file or to append it. So let's look at the different special characters for redirection. We have the greater than symbol that redirects standard output to a file, but it overwrites a file, which means, let's say I issue ls, which lists contents of home directory, and I redirect it with one greater than symbol to a file name. If the file does not exist, it creates the file with the output of the ls command. If the file does exist, well, it'll overwrite whatever file is there before and put the new contents of the file, which again would be the contents of the directory where I issued ls. We also have two greater than symbols. This redirects it, but rather than redirecting it and overwriting it, it redirects it and appends it to the file. So if that file doesn't exist, same process, it would create the file. But if the file does exist, rather than deleting what's there and overwriting it, what it will do is it will add that text to the end of the text that's already, or the contents that are already there. We have the to and the greater than symbol. This is done to redirect standard error. One thing you want to keep in mind is the data streams have different values associated with them in terms of numbers. Standard output would technically be a 1. Standard error would be a 2. So with standard output, you don't have to put that 1 before the greater than or two greater than symbols for overriding and appending standard output. But with standard error, you have to differentiate between standard output and standard error. So you're going to use a 2 and then a greater than or double greater than symbol, depending on if you're trying to overwrite or append. Again, one greater than symbol means you're overwriting. Two greater than symbols will mean you're actually appending a file. You also have the ampersand and the redirection symbol, greater than symbol, as well as the ampersand and the two greater than symbols. This will be done to redirect both standard output and standard error to the same file, either overwriting it if it's one greater than symbol or appending it if it's two. And then we also have the less than symbol, which is used to redirect standard input from a file into a command. Now, ultimately, as I mentioned already, overwrite means you're replacing current information with new information. Append means you're joining or adding something to an end of a file. So here's an example of overwriting in terms, or redirection in terms of overwriting standard output and appending it. So we issue the command echo and 1, which is simply just going to print echo. Actually, in this case, what this is doing is if I just typed echo and then 1, it would print echo. Since I did the redirection symbol, it redirects it to a file called test. Then I can use the more command to read the test file, and it displays the value of 1, because again, echo will basically print this to the terminal, but since I'm redirecting it to a file, it prints the value of 1 to the file. Now I could do echo 2 and then redirection to test. So keep in mind, the test file initially had 1 in it, but since I redirected this output of 2, which again, this would typically just display 2 to the terminal, I'm redirecting it to this test file that already exists. So it already exists. The contents of that file have been erased. The contents of it are now 2. Again, it's overwriting the file. With appending the file, it's going to look more like this. I'm going to type echo and 3. Again, this would typically just display 3 to the terminal, but I'm redirecting it to the test file. The file does exist, so it's not going to recreate the file. But notice I'm using an append as opposed to overwrite, which means if I actually read the file, it will include the value 3 after the contents that were there before, which was the value 2. So here's another example of redirecting standard output. Again, it relies on the greater than symbol. In this case, in terms of overwriting, if I want to do appending, it would be 2. But I could, for example, type cat/etsy/pastwd. Cat was basically going to be used to read the contents of the pastwd file in the Etsy directory, which again is user information. And I'm redirecting it to the pastwd.txt file. Only standard output will go to this file, standard error will not. Now, notice there's no errors, so if there's not any errors, you're not going to have any issues. Now this down here is as if basically showing output. Again, no errors. If I redirected this, again, what I would do is if I wanted to redirect it and override, I would put 1 greater than symbol. If I wanted to append, it would be 2 greater than symbols. But basically what this command down here is doing is simply just listing the permissions of this past WD text file. Also proving that it does exist, of course. In this case, we're using standard input as a redirection for standard output. Or excuse me, we're using standard input as a redirection to write a file into a command. For example, this case, if I typed cat-n with the less than symbol and then the file path /etc/passwd, what this does is it reads the passwd file into the cat command and provides a numbered list. Now, oddly enough, I don't necessarily even have to include this less than symbol. I could do it without the less than symbol and it does exactly the same thing. So really redirecting standard input is not, in most cases, a necessity, but there may be some situations where you do have to use it. And finally, we have redirecting standard error. So for example, let's say I issue the command find, and then I do a /, and then I issue name, try and basically find names that match .mp3. Now, if I just issue this command without redirecting it, it's going to give me errors. So, but if I wanted to redirect the error, I do provide the 2, the overwrite or greater than symbol, then I ultimately send it to a particular file name. In this case, the file name is find errors. So let's look at this for example. If I issue this command by itself, again, I get error messages. But if I redirected the error messages to this file, I won't get any output. But if I want to view whether or not it was successful, again, I can use the more command to read this file. And you'll notice I have the same output as if I would just run the command and have error displayed to the terminal. All right, so here's a list of my sources for this particular material. And now I'm going to open up the terminal and walk through both redirection and piping. All right, so I'm going to go ahead and open up the terminal. And I typed the wrong password. If you ever forget your password, I will be creating a video on how to reset a password as well. If it's the only user you have on the system. Now, if you have other users on the system, you could ultimately log into that user and reset it. But I'm going to show you different methods of how to reset user passwords in later videos. But ultimately, and of course, if you have that issue, I will ultimately allow you to refer to those videos on YouTube. But ultimately, you want to make sure you do type the correct password. Now, while I'm in the terminal, I'm going to go ahead and clear based off of previous work I had done. And I'm going to explain standard output, standard error, and standard input. So I issue the command ls. Again, ls lists contents of directory. I notice that I have output displayed to the terminal. This is output because there are no error messages associated with it. All of this on the terminal is considered standard output. Now let's say I want to see an error. Well, in this case, I just issued ls and then I just put adf. Basically, it's wanted to list whether or not this file exists, but the file doesn't exist. And since it doesn't exist, it's coming with an error message saying you can't access this file. So this, in this case, is an error message. It could also be done if I was trying to read a file that I don't have permissions to read. So let's say, for example, I try to read this file. In this case, I have permissions to read it. But if I wasn't a user that didn't have permissions, what I would see is something telling me I don't have permissions to execute that particular command. Again, I do apologize for that. Now, let's say I have standard input. Well, as I mentioned, standard input is basically either me typing text into a terminal, like cd tilde. Again, this would technically be standard input. Or I could also be issuing a command. I could be using the redirection symbol to read a file into a command as well. That would be input. So again, you have input, then if I do input like ls, I have output. But if I issue a command that doesn't work properly, then I get standard error instead. Again, output is anything that's output, not error messages. Standard error is anything that is an error message, not just normal output. All right, now let me discuss the use of redirection. So I want to redirect standard output. Let's say I issue ls. And rather than having it display at the terminal, I want it to actually display to a file named home directory. So I do my greater than symbol, and I type the file home directory. And notice that there's no output displayed at the terminal. What does this mean? Well, it means that what we wanted to do was successful. What we wanted to do is we wanted to direct this output to this file, and once we ran the command, it did so. I can issue ls now. I can see that the file does exist because it created the file. And now I can actually read the file as well using cat. If you'll notice, it lists the contents of the directory just as if I had issued the ls command. So that's how you would redirect standard output. But again, remember, these one greater than symbol is overriding. Two greater than symbols is to append. So let's say I want to append this file. I want to issue the command @/etc/passwd, and I want it to append to the file home directory. Notice I have no output, which means that, again, the command was successful. I issue the command cat and home directory to actually view the file. And you'll notice that if I scroll up, not only do I have the previous contents of the file, I have the new contents listed as well. So again, you have the option to append or to overwrite. Now let's say I am working with standard error. So I do like find this, and it comes up with an error message saying no such directory. Let's say if I just redirect it to the file that I just created, which is home directory. This file already exists, but since I'm overwriting, it should, in theory, overwrite any output that's displayed. But notice I'm still getting the error message. That's because I didn't actually redirect standard error. I just redirected standard output. Read the file. Well, it overwrote the file, but notice now there's no output. So again, if I do redirection and I make a mistake like this, because I'm trying to redirect standard error and I redirect standard output instead, if I use this symbol, it'll overwrite it. ls again. And this time. And let's say I append this error message or append this command. Again, I don't have any output with this command, I only have error. So I still get error message displayed to the terminal. Notice now when I read the home directory file, everything's still there. So again, if you are redirecting standard error, you're trying to redirect standard error, but you don't do it correctly. If you just do the one greater than symbol and overwrite, unfortunately, everything you did was gone. But if you just did append, luckily you don't lose anything. That's an important distinction to make, because you may be a chance where you're trying to redirect standard error to the same file that has standard output in it. And what happens is effectively you do the wrong operator. Well, if you do the ampersand or the two greater than symbols, at the very least, it's only appending, which means you won't lose anything. But if you do one greater than symbol, it's overriding, so you do lose everything. But let's actually try to redirect the standard error. Now, if I want to redirect standard error to a different file, then let's say I just type find, and then I type this some random text. And I do the 2 and the greater than symbol. And then I type the file error or name error. I issue ls. You notice that I have a file called error. Notice that no error was displayed at the terminal when I issue that previous command. And now let's actually read the error file. You'll notice I get the error message displayed to the file. Let me run another command. Again, it's going to tell me basically the same thing, that this particular file doesn't exist. Let me redirect that to this file, but instead of using the overwrite, which is just one greater than symbol, I do two greater than symbols. I put the name of the file, which is error. I read the error file again. You'll notice now I have both error messages, the previous error message and then the error message that was appended to this file. Now I'm not going to, I could do standard input. I'm just going to pull up the PowerPoint to use the same example they used previously. So I'm going to do cat slash I'm going to do forward slash, or less than symbol, excuse me. I'm going to do forward slash etsy slash passwd. Notice it's going to read the file, and what it did is similar to just simply just typing slash etsy slash passwd. This would be redirecting standard input, but let's say, for example, I just type it without the standard input redirection symbol. Notice it does the same exact command, same output. So again, you're not going to find a lot of times you're going to redirect standard input. You might find a few times. Most of the time, you're going to be redirecting standard output or standard error messages. All right, another concept we discussed was piping, so I do want to go over that quickly. Let's say, again, I want to read the cat slash etsy slash passwd file. And notice that I get all of this text displayed. I get every single user on the Linux system. Now, let's say I just wanted to find my username, which is Kyle. Again, I can type cat slash etsy slash passwd. I can use the pipe character, which again is the shift and the backslash key. And then I can type grep, which is again grabbed regular expressions. It's going to search the file for the search term. In this case, the search term is Kyle. And notice that rather than displaying all of this output, it only displays output that is associated with my username. I can do the same thing when I'm using, I can use piping and redirection as well at the same time. For example, let's say I do this command. Rather than having it display to the terminal, I just send it to a file called user info. Notice no output again is displayed in the terminal. I read the file user info, and notice that it has the output for my particular user. Let's search that file for another user. Notice it'll show information about root. It also shows information about anything else that's referencing root. In this case, I could use certain command options to only have to display the first line. I'm not going to do that here, but effectively you'll notice that I have this information displayed in the terminal. And I can redirect it, but not overwrite, by using the two greater than symbols to append instead. I can use user info. Then I can read the user info file. I can use cat. I can also use more. And notice that I have not only output that was there previously, I also have a new output included as well. So this wraps up the discussion for this video. Again, we explained the different data streams, standard input, standard output, and standard error. We also explained the uses of redirection and piping. Again, redirection is used to manipulate those data streams to send them to a file or read a file into a command if you're talking about standard input. And with piping, piping is done to take the output of one command and use it as input for another. So again, thank you for taking time to watch this video. Again, if you have any questions, feel free to email me. I will include my email, the details of the video. You also feel free to put any comments as well, and I'll do my best to respond to them as quickly as I can. Again, thank you for taking the time to listen, and have a nice day.